Welcome students, welcome to another session of tutorial classes of C++. Our today's topic will be continuing on the inheritance. Okay, so today I will tell you about a new access specifier called protected access specifier. Okay, up to now we know about two access specifiers used in classes of C++. One is private and the second one is the public. As we know that private members of a class cannot be accessed from outside the class. Okay, only other members of that class can access them, and the public members can be accessed from outside through an object of that class. Okay, so now when we are learning inheritance, we came to know about a third access specifier called a protected access specifier. Okay, so what protected access specifier do? It actually acts as a private while accessing them from outside the class. That means it cannot be accessed. The members under protected access specifiers cannot be accessed from outside the class, but they are inheritable. Okay, if you want to note it down, you can note, I am repeating, protected is an access specifier member of which can be inherited to a subclass, but they are not accessible from outside the class. Okay, and when we inherit a class with a protected access specifier, if we inherit the class publicly, the protected members will become public members of the class. If we inherit the class privately, the protected members will become private members. Okay, there is no way to make them public members in the derived class. So let me explain the protected access specifier by using a example. So as you can see in the program, I have taken three classes. One is class A, another is class B, in which we are inheriting class A publicly, and the third class is class C, in which we are inheriting class B. So here we are creating a multi-level hierarchy of classes. Okay, in class A we have two member variables. One is x, which is a private member variable. Another is y, which is a protected member variable, and we use a constructor to initialize them. Now inside class B we have taken a public member display. Okay, and inside the class C we have taken another public member show, and in the function display we just print the value of the protected variable y. Okay, and now in main function, first let me create an object of class B. So we call the member function display via object of class B, and let us access the member y, which is a protected member of class A, directly from outside the class A. Okay, cout, I am just printing the value of y directly, not through the function of class B, obj.y. Okay, so let me compile the program first. So we are compiling the program, and after compiling we see that there is an error which is telling that y is a protected within this context. That means we cannot access y from outside the class. Now let us make the line which is generating the error a comment line and compile the program again. Well, now you see the output 20 which is assigned to y. Okay, so now let us change the program a little bit. I am creating an object of class C also, obj C. Okay, and let us access the function of obj C, which is just printing the value of y. obj C dot show. Now compile the code and let us see the output. Sorry, my mistake. Let us compile the program again and see the output. So what we see, the variable y is accessible from both from the class B and the class C. So what is the conclusion? Protected members are not accessible from outside the class like a public member, but they can be inherited and can be accessed by the other members of the derived classes. Okay. Our second topic on C++ today is ambiguity in inheritance. What is ambiguity in inheritance? Actually, ambiguity arises in inheritance when both the base class and the derived class has a member of same identifier. That means we have a variable in base class. Suppose that the name of the variable is class. The name of the variable is A. Okay, and we have another variable in the derived class which has the same name A. So if we access that variable from an object of the derived class, which one will be invoked? Normally, the local member will be invoked because it has a higher priority. This causes an ambiguity in inheritance. So there is no way of invoking the member which has the same name in the base class. Okay. Let us check it through an program first. Let me type the program for you. Has include IO stream using namespace std class A. In class A, we are taking a function void show. This is class A. And now we are taking another class, class B, which has the same function named show, and we are inheriting class A in class B, public A. So now what happens? Class A has a member named show and class B also has a member named show. So if we invoke the function show by an object of class B, then only the function of class B will be invoked and the function of class A will not be invoked. So let us check it. It means B obj dot show. It will always invoke the member of class B because it has a higher priority. Okay, let us compile and run the program. Oh, sorry. Let me make them public first. compile the program. So what we see, it invokes the member of class B. Okay. So what we should do to resolve the ambiguity? We just use the scope resolution operator to invoke the member function show of class B. What will be the syntax? Obj dot a scope resolution operator show. It will invoke the member function show of class A. Let us check it. See, first it has shown this is class B, and after that this is class A. So if both base class and derived class has an identifier of same name as a variable or a function of same identifier, then we may access the function or variable of the base class by using class name followed by that scope resolution operator. Okay. And now the third topic of today's discussion is sequence or how to invoke constructor in inheritance. How to let us make a program. Let us write a program first, then I will explain it. Okay, as include IO stream using namespace std. Actually, if my classes in inheritance do not have any parameterized constructor, then it's okay. But if the base classes have parameterized constructor, then it is the responsibility of the derived class to feed them or to send argument to them. Okay, let us take class A with two members int A, int B, and a public constructor, parameterized constructor int xy, A, x, B, y. Okay, and another class B, another class say P, int P, int Q, and public constructor P x, P y. Okay, we have initialized both class A and class P's constructor with arguments. Okay, and let's take another class, class X, and take two variables. Say okay, let us leave this class and continue with these two classes. Okay, now we are inheriting class A in class P, public A. So now it is the responsibility of class P to send the argument to the constructors of class A. So what should we do? We have to, if the base class constructor have two argument, then the derived class constructor constructor must have two arguments and additional arguments for its own variables. So, in my program, the constructor of class P should have four arguments, int P, int Q. Okay, and we have taken X and Y for its own, and the next two arguments must be sent to the base class constructor, okay, via this syntax. So, when we create an object of class P, we should supply the constructor with four arguments, two for its own variables and other two for its base class variables. Now we are taking a function void show to display the values. Cout A, B, P, P, Q. Okay. To do this, we have to make variable A and B protected, because if we do not make them protected, they will not inherit to class P. Okay. So now let us take the main function int main, in which we will create an object of class P, P obj with four arguments, 1, 2, 3, 4. Okay. So 1 will be assigned to variable X, 2 will be assigned to variable Y, 3 will be assigned to variable P, and 4 will be assigned to variable Q. And the variable P will be assigned by the variable X, that means 1. Variable Q will be assigned by variable Y, that means 2. And the last two variables P and Q will go to the constructor of class A and will be assigned to X and Y. That means 3 and 4 will be assigned to P and Q will be sent to the constructor of base class A and will be assigned to X and Y, and A will be assigned by the value of X, which is 3, and B will be assigned by the value of Y, which is 4. So if we invoke this function, we will just see 1, 2, 3, 4. Sorry, 3, 4, 1, 2. Okay. Let us check. Sorry, this is a silly mistake. Multiple initialization of P. Where is the multiple initialization of P? Oh, sorry. Let us change the variable m and n, because of class P have two members P and Q. It will create an ambiguity. Okay. Let us save the program first. Say 3, 4, 1, 2. Okay. So see this video carefully, and we will be coming with another video session